Welcome everyone. The objective of this lecture is to understand design of half subtractor. So half subtractor is one type of combinational circuit. And already we have seen how to design combinational circuit, which are different steps that we follow while designing combinational circuit. So same steps we are going to follow here also. So first of all, we have to understand what is half subtractor. So half subtractor is a logical circuit which is used for subtraction of two 1-bit number. Then it has two inputs. Okay, so suppose assume that two inputs are A and B, and it has two outputs. And here, what is size of each input? C. Size of each input is 1-bit number. Same as that of half adder. Half adder does addition of two number, and size of each number is 1 bit. Okay, similarly half subtractor also does here subtraction of two number, and size of each number is 1 bit. Here we are going to consider A as a minuend and B as a subtrahend. That is, we are going to perform operation A minus B. So this is block diagram for half subtractor. A is input, B is input, and two output D and B out. D stands for difference and B out stands for borrow. Now let's try to design truth table for half subtractor. So as half subtractor has two input and two output, how many column will be present in this truth table? 4 column. Okay. Now see 1, 2, 3, 4. So first of all, what we have to do? So first of all, we should write, in order to design this truth table, first of all, we should write all input combinations. So as there are two inputs, how many input combinations are possible? 4 input combination, 0, 0, 0, 1, 1, 0 and 1, 1. Okay. Then you have to write corresponding output for each input combination. So consider first row. In first row A and B, they are 0, 0. So what output or what operation will be performed by half subtractor? A minus B. Okay, so A minus B. So 0 minus 0, difference will be 0. And borrow will also be 0. Now consider next row. So 0 minus 1. So 0 minus 1, we are subtracting larger number from smaller number. So in this case, see, difference will be 1. Okay, 0 minus 1, difference will be 1 and borrow will be generated, as we are subtracting larger number from smaller number. Then consider next input combination 1 minus 0. So 1 minus 0, in this case difference will be 1. Okay, and no borrow. And for last input combination 1 minus 1. So 1 minus 1, difference will be 0 and borrow will also be 0. So this is truth table for half subtractor. Now let's try to represent the information in truth table on K-map. So what type of K-map we should use? 2 variable, 3 variable or 4 variable? So we know that type of K-map depends on how many inputs that particular digital circuit has. So this half subtractor has 2 inputs, so that's why we should use 2 variable K-map. Then how many 2 variable K-map? How many 2 variable K-map we should use? So it will depend upon number of output. So half subtractor has 2 outputs, so that's why we should use 2 K-map, one for difference and one for borrow. So see, first of all, let's try to draw K-map for difference. So K-map for difference will be like this. Okay. So in this K-map, grouping of 2, 1 is not possible. These 2, 1, they are not adjacent to each other. So that's why we have to make group of this isolated 1. So here we have 2 groups. After making the group, what is the next step? We have to write product term corresponding to each group. So for this group, see, what is the value of A? A is 0, so that's why A prime. What is value of B? B is 1, so that's why B. Okay, so A prime B is a term which is corresponding to this one. Similarly, A B prime is a term which will correspond to this particular group. Then we can write equation or expression for this difference as D is equal to A prime plus A B prime. So just we have to take OR operation between these two terms. And again observe this expression A prime B plus A B prime. So this is expression for XOR operation, XOR gate. Okay, so we can rewrite this expression as XOR operation between A and B. So XOR operation between A and B will give me difference. Now let's see K-map for borrow. So K-map for borrow will be like this. So in this K-map we will have only single 1. Okay, so make group of this one. After that, write down product term which is corresponding to this particular group. So see, for this group, what is value of A? A is 0, so that's why A prime. What is value of B? B is 1, so A prime B. Okay, so I can say that B out is equal to A prime B. Okay, Then what is the last step? So we have got expression for difference as well as expression for b out. So we have to draw the logic diagram. So in order to implement expression for difference and expression for borrow, how many gate we will require? Yes, so we will require 3 gate. One is XOR gate, then second one is NOT gate, and third one is AND gate. So logic diagram for half subtractor will be like this. So see, these are the two inputs A and B. Just now I told you that we will require 3 gate XOR, NOT and AND. So XOR operation between A and B will give me difference. Okay, and then see here we required A NOT. So A is given as input to NOT gate. So here I will get A prime, and AND operation between A prime and B, and operation between A prime and B will give me BOR. In this way we have designed half subtractor.